Hello and welcome back to the lab. Today on the bench we have hopefully the last piece of Cal gear that I have to look at in a while. We have a Vahalla Scientific 2500 EN. Now there's a couple different models on these if you're looking for one. I've really needed one for a little while, but I haven't been sure what to get, and I was fudging not having one with my source measure unit. However, the source measure unit does DC current very well. This particular unit does AC and DC current. So the main differences between the 2500E, EP, and EN are the input impedance, the compliance voltage, and the control voltage. So on the E model, you have a 100 kilo ohm input impedance. You have a 0 to 1 volt control voltage, and you have a 10 amp full scale out for the current source. So the compliance voltage on that one, I believe, also goes to 10 volts. On this one, we have a 0 to 20 volt control voltage, and believe it's a 10 volt compliance voltage on this one. I'm not 100% sure, or I'll have to check the documentation for that. Now, because it's a current source, ideally you shouldn't, whatever you're pushing current through, should not develop a high voltage drop across it, because we're interested in current, and this is one of the main usages for this piece of equipment, and the way I'm going to use it is doing current calibrations on multimeters. The important part about this is I can do up to a 1 kilohertz sine wave in to align DMMs, AC current ranges on DMMs. Now, this piece of equipment became very critical because in the near future we're going to have a DM 504 on the bench that's microprocessor controlled and is going to need, once you start the calibration procedure on that, you can't stop or it doesn't save. So I'm going to need this to get through the current section, because I need positive and negative currents, and I need AC currents as well. And this unit can do all of the above. When you put a sine wave input at the control voltage, you get a current output, not voltage output, but current output that is at the same frequency and the same phase as the control voltage on the input. That is a fancy way of saying the best thing that this can do, or I should say, for what this unit can do, this is a giant op amp. So what I'm expecting on the inside is I'm expecting giant caps on the power supply, some really nice pass transistors on stout heat sinks for the current elements, and going from there. So we have a current range here, and we have an input equals 10 volt. So if I select this range and I put 10 volts here, I will have 1 amp here. That can also do a positive or a negative 10 volts. So that's how you control the current source on this one. Now, ideally this is a ideal current source. An ideal current source would be able to reach an infinite voltage, similar to the SMU, up to its output. This tops out at 10 volts. So it's really designed to drive shunts, things like that, with known currents in AC and DC, also of both polarities. You can have negative current, i.e. a negative supply, pushing through a load. This does not create power. This is not an infinite energy machine at all. This burns a lot of watts, actually. It's forced air cooled, but it can produce current in a negative polarity. The EP version of this is just programmable. The E version of this, it's a 0 to 1 volt, and it's less on the compliance voltage. I don't remember what it could top out at. No, I think that's it. The compliant voltage on this unit is 20 volts. The compliance voltage on the E unit is 10 volts. I think that's the way, if I remember the data sheets correctly, that's the way that goes. So, for this particular one, it came from a popular auction site. It was in very nice shape. I am very happy with the front panel on this. It was very well taken care of. I do expect it to function, but we're going to test some of that today and take a look inside this thing and see what's going on. So let me get the camera repositioned and we'll take the covers off and see what's inside. All right, I've repositioned the camera up top and we're taking a look at the back of the unit. We have 2 fans, 1 fuse, and a power connector, and that's it. The back is very uneventful. So we will get the top off and take a look. I am expecting lots of heat sinking, big beefy wires, heavy traces, decent current stuff, because this will, at its highest range, produce 10 amps, which is quite substantial for current. This has me a little concerned. The lid's out of its track, so we'll see if we can't get that squared away and fixed. Hopefully the chassis is not too bent out of shape. Doesn't look too bad, but can't complain, as when I looked for one of these, this was the only option. Woo! All right. It does appear that the lid is bent a little bit. I don't know if the camera's picking up that warping. So what we're going to do is we'll tap that flat with a nice hammer without marring anything up. There's our nice beefy heat sinking. It's chimneyed, so it's pulling air in, blowing it out the back, and everything looks good there. However, where's the intake? We have lots of out. Oh, the in's over here. Duh, there's no fan over here. So airflow is going to go this way. It's going to be pulled in across the transformer. These big giant caps come around here. Those are, holy crap, they are huge. 55,000 microfarads at 40 volts working volts DC. So not a ton of voltage, but there's current behind there. Holy cow. And we do see one's wired up with the black and one's wired up with the red. So this is probably going to be our positive and negative supplies going into there, I would suspect. But nice big beefy parts there. We have Precision City down here in the front. I do not want to touch any of these boards for current leakage or anything like that, but here's our pass elements. And those are both red wires. Let's see, what are these pass elements? Are they all the same? I wouldn't expect them to be, because we have positive and negative supplies. So it looks like we have 2N 6247s on the right and 2N 3055s on the left, with some very high current ceramic balancing resistors and things like that. We do have a couple of set points. Down on the board, and I'm wondering if that's some form of reference. I don't know what that is. That's looks like it's got 4 wires. They're snaked together and they're smashed between heat sinks with insulating material on the back of it. So that's interesting. We have standard equipment switch blocks for the day. Those will need cleaned and serviced. But other than that, everything looks good. So I don't see anything too crazy that could go wrong. These electrolytic capacitors are going to be fine, especially when they get that big. I rarely see anything fail. Also, we're dealing with a low-speed supply because even at the highest current, it's 1 kilohertz, so it's not anything crazy, so we're not going to get a whole lot of self-heating on those. The other thing is, typically when you get into caps this size, they tend to be run very conservatively, so I don't expect there to be any issues with those. That switch pack may be a problem, but as long as the current elements are okay, there is not much to go wrong with this thing, which is cool. Having a bunch of tiny electrolytics on the board and having them blow up all over the place would have been quite unfortunate. All right, I've got the lid a little bit bent back into shape. Not quite yet, but I want to fire this thing up. So what we are going to do, because I don't want to lose the chimney effect on the cooling, especially on those pass elements, we're going to get the lid put back on as soon as I work around the camera. All right, so we have the output hooked up to the DM-M6510. We have the input that's going to be hooked up in positive polarity to the Keithley 2281. And we are in standby mode. One thing the manual does say on this unit is to make sure this is in standby mode before connecting and removing any load. That is to keep the compliance voltage from going to the moon, this being a true constant current source. If you unplug this, obviously the unit's off, it's in standby. If you unplug this, it's going to shoot the voltage at these terminals all the way to the rail to try to push current, which is what we don't want to do. Also, for the current side of things, I don't like how shallow these banana plugs are in those jacks, so we are going to get a bit better and chunkier connection to these current posts. Okay, so I have 1 amp selected, and we're on. Ooh, that's got some fan. This really does move some air. That fan revved up. I'm going to know when this thing's on. It's not as bad as my Fluke AC calibrator, the 5200 or the 5205. But I definitely, it's moving some air through here. So this is no joke. This is not messing around with its cooling. So let's give it a volt. And let's take a look at the meter. I haven't turned the power supply on yet. Don't know if it works. So we're on the 1 amp range. I have 1 volt going in. So in theory, I'm looking for 100 millivolts or 100 milliamps of current if everything works like we think it's supposed to. So I'm drawing about 5 milliamps of current from the supply. Nothing major there. I'm about to hit operate. Looks good to me. 999, and we are not warmed up yet, so absolutely this looks like it's working exactly the way it should. So I'm going to let this warm up for a little bit. I'm just going to let it dump some current in this meter. 100 milliamps isn't going to hurt anything. Just let everything kind of stabilize and just see how accurate it is. We'll clear the buffer. Let's give it the full 10 volts. That's 2 volts. 3, 4, 5, 6, 7, 8, 9, and 10. That's an amp. I am ecstatic about that. It's working exactly like it should. So I'm just going to let it burn in, stabilize. We'll see where it's at. So I'll bring you guys back here in about an hour or so. So just thought it'd be fun to walk it up through the decades. I can't do the 10 amp range because this meter is only good for 3 amps, so that'll blow up the fuse in the meter. That would not be a good day. But we'll start with 100 microamps, and I can even dial microamps. Like, let me go down. So I'm dialing tens of microamps of current. The only other device that I have in a lab that can do this is the SMU, which is actually kind of cool at this level. So there's 100 microamps full scale, 1 milliamp, 3 nines, 10 milliamp, 100 milliamp. I'm just kicking it to standby now between ranges because as I was pushing the range switch, I saw the compliance voltage peak out for a second. And back to our 1 amp range. Not unhappy with that at all. I can't ask for anything better. This is also my 6500, so this is not the highest precision meter we have in the lab. Most of the calibrations and stuff that I've done are referenced to the 7510, which is a 7.5 digit meter. And the 7510 has a much, much better internal reference than the 6500 does, so its stability is a lot higher. So this stuff bouncing around at the end doesn't concern me at all. Okay, so I've let the unit warm up for a while and run. And according to this meter, the unit's out of spec. However, that could also be this meter, because the accuracy specification for the 1 amp range is plus minus 0.01% plus or minus 400 microamps. So that should be 9999 with a bare minimum of 9995, taking into account the lowest of its tolerance. So this is measuring it out of specification, but that could also be the tolerance of the 6500. So I really need to check this on the 7510. The reason this DMM doesn't get a lot of love in the lab, at least on the camera, is because it's slow. This is one of the things I was talking about between the 6500 at its fastest update speed and this thing. This is almost 50 seconds of measurement, I think, when it's on its absolutely slowest setting. So it does take good measurements, but for catching transients, it's very, very slow. The compliance voltage is the voltage measured across, this is what's developing across the shunt resistor in the DMM 6500. Okay, we have a couple more connections to the 2500. I was having some trouble with the 6500 reading the compliance voltage, or not the compliance voltage, the current. It was reading out of spec. That could be a couple things. This could need to be calibrated. This could also need these switch packs cleaned. But, so I changed some things. I'm now monitoring the voltage on the input to make sure it was stable to 10 volts, which it is. We're not bouncing very much. Actually, I think I may bring it down to see 10 volts even. And I'm also warming up the 7510 because the accuracies and measurements specified for this particular unit are done on a HP 3458A. Do not have one of those in the lab. The 7510 is the best meter I've got. But it is well the 6500 is well out of spec for being able to measure this. The noise of the 6500 is more than the noise of this. So I'm not condemning the 2500 yet as needing an adjustment or anything. I am going to dial back the power supply voltage so it is 10 volts as accurately as I can. And I'm going to let the 7510 come up to temperature. I have an hour and a half warm up on that I have to wait for. And we'll go from there. Taking a look at over here real quick, though. We have this meter right here. We'll zoom in. So this is measuring the compliance voltage across the current shunt in the 7500 or 7510. This is set in 6.5 digit mode. This is typically a 5.5 digit meter. However, with sampling, filtering, and averaging turned on, it will add a 6 digit and be a 6.5 digit meter, but only on the 10 volt scale. That's just a limitation of that particular meter. Nothing too terrible. The other reason it doesn't get a lot of love in the lab is it's a little slow in terms of the when you stacked up against the 6500 or the 7510. The 8505's update rate is a touch slow, but not a problem. Still very functional and does see some use. So what we're going to do now is we are going to dial back. So I can't actually control the last 2 digits on the power supply. So without firing up the fluke power supply, I'm stuck at that resolution. Well, after everything's all warmed up and everything's rolling, we are out of spec. So 9991 to be in specification, this would have to be 9995. We're out by about 400 microamps, and that is including the tolerance at the low end. So, well within the adjustment range of the unit, I'm sure. However, given the accuracies of DMMs, this unit is adjusted with a resistance with some shunt resistor standards, which I do not have. So, I also need some of those shunt resistors to handle about 10 amps. So, I'm going to have to order some standard resistors to work on this unit. Fortunately, I did check the specification of the 7510. Is good enough to do the alignment. I do not need an HP, the 8.5 digit HP. I do not need that for doing this unit. The 7510 will be fine. The service manual would like a 3 ppm unit. The 7510 is a 1.4 ppm unit. Or, I'm sorry, a 30 ppm unit. The 7510 is a 14 ppm unit, so I actually have twice the accuracy I need, even though we're getting down into the splitting hairs level of territory. For the input voltage, I am going to need the 343 because I have to do all of these with a very stable 10 volts. And my Keithley power supply was good enough for testing, but not good enough for doing the calibration. Now, if anybody thinks the Keithley might be kicking it out of calibration, we're even giving it a hand because I'm putting 700 microvolts more voltage into the front end than I am. So this should be about 700 microvolts or 700 microamps higher than it is, and so we are still off. We will unplug the meter just to be safe. We'll just pop the meter out of circuit. Nothing really changed, although we got a little bit of action on here while it settled, but then it settled back down, so the meter impedance wasn't causing it any heartburn. So we do have a unit that needs adjustment. Not a problem. We can do the adjustment. I just need to get shunt resistors. So, as always, sometimes in the lab, we take one step forward and half a step back. In this case, we did. Not a problem, though. The shunt resistors are probably the easiest side of things to pick up. So, I hate that setting. I really wish it was green when it was operating, and it was not green when it was in standby. That's very confusing. Make sure something didn't happen real quick. Give it input voltage. Set it to operate. Yeah, we're fine. So, we will do this the correct order now. Stand by. Turn off the input voltage, control voltage, and shut down the unit. So, as always, I hope this helps get labs off the ground. I will see everybody in the comments in between videos. More is always on the way. And this will see the bench again. I just need to wait on the shipper. So, if there's any questions, comments, or concerns, hit me up in the comments between videos. Patreons are running about, I think, 3-ish videos ahead now these days. So, if you'd like some more and to be a little bit ahead, check that out. And I will see everybody in the next video.